So we already know why we use numpy arrays over list, and if anybody asks you about the differences between them, you can answer it confidently. Now let's understand numpy more deeply and get ourselves more comfortable with arrays. We now know what an array is and how to create it using few simple functions, but today I will be showing you how we can fetch out the elements from a created array using one of the important techniques known as indexing and slicing. So make sure you watch it till the end to master this technique so that you never get stuck while fetching elements from any array. So before diving into the super important techniques of fetching out the elements, let me show you few more amazing functions of creating arrays with the elements of your choice. So let's head to the screen and see few more functions to create arrays with random elements or elements of your choice. So let's say I want to create an array with few random numbers in it from a particular range. So I will use np.random. Now inside this random we have a function named as randint. So if I give a range here like 1 to 20, it will generate a single random number within this given range. So if I run it, I get a random number. If I run it again, I will get another random number between 1 to 20. If I pass another value here, which is the number of elements, if I write 5, I get 5 random numbers from 1 to 20. Similarly, I can give here 15. You can give any number you want. Next is the rand function. It's np.random.rand. Inside it, if I pass a size, it will give me an array of the given size between the values 0 to 1. So if I give any size, I will always get the values inside this array from 0 to 1. The next is linspace. If I write np.linspace, pass my range, and if I say I need 5 numbers and run it, it will give me 5 equidistant numbers from the given range. If I write here 15, it will give me 15 equidistant numbers from the given range. Also, it will include the end value and the starting value. Next function is identity. If I write np.identity, and I pass an integer here like 5, it will give me an array of 5, 5 shape with the diagonal element as 1 and the rest of the elements as 0. If you want to change the diagonal elements, just multiply this with any number, let's say 2, and I will get all the diagonal elements as the given element. Next is ones. Now this function is used to create arrays with all the elements as ones. I will write np.ones, pass the size, let's say 5. I get an array with 5 ones. If I pass the shape inside a tuple, like 5 cross 5, I get a 5 cross 5 array with all the elements as 1 in it. So this way you can create few more arrays with the elements you want in it. And now you are a master in creating any type of arrays you want, and it's time for us to understand the techniques of indexing and slicing on various arrays of various dimensions. So let's head to the screen again. So we'll be seeing how to fetch elements from 1D, 2D and 3D array, and similarly then you can fetch all the elements from n-dimensional arrays. So here, as you can see on the screen, I have a 1D array which consists of 20 elements from 1 to 50. Now let's say I want to fetch the number 44 from it. So I will write array1 square brackets and count the index number of it, that is 0, 1, 2, 3 and 4. Pass here the index number, that is 4, and run it. I can fetch 44. Similarly, if I want to fetch 25, so if I pass here 10, I will get the output as 25. You can also play with negative indexing here. I will write array1 and fetch out the last element by giving -1. I can get 20. If I want 11, I will write -3 and I can get 11. So indexing is used to fetch out the element on that particular index. When we have to fetch out from a range of indexes, we will use slicing. So let's say here if I want elements from 11 to 22. So first I will count the index number, that is 0, 1, 2, 3, and from 3, 4, 5, 6, 7. From 3 to 7. So I will come here and write R1, and here I will give my index number from 3 colon, here we will give n plus 1, that is 7 plus 1, 8, and if I run it, I get 11 to 22, which we needed here. Let's try indexing on a 2D array. So here I have a 2D array with random elements from 10 to 20. So if I apply the same logic here as we did in the 1D array, let's say I want to fetch this 12. So the index number is 0, 1 and 2, and I pass 2 here and run it, it will throw me an error. Because here we have two arrays. So if I need this 12, I will first check in which array it is. So as we can see, there are two arrays and it is in the array number 0. So here we will write 0, and then in 0 it is on the second position as the index number is 0, 1 and 2. So I will write 2, and if I run it, now I can fetch 12. Let's say I want to fetch 18, and it is in the array number 1, as this is the array number 0, this is the array number 1. So I will write here 1, and the index of 18 is 3. I will write 3 and run it, I will fetch 18. Similarly, you can perform the negative indexing. I will add R2, pass the array number, let's say I want 14, I will write 0, minus 1, and I will get the last element of the first array, that is 14. If I change the array number, I will get 19. Now let's see how the slicing works. If I write R2, let's say I want to fetch 13, 14, 18 and 19. So I will write R2. So as we want both the arrays, I will use a colon here. Use a colon when you want to include everything. Then we will pass the column number, that is 0, 1, 2, 3 and 4. So I will write 3 colon, and if I run it, I get 13, 14, 18 and 19. Similarly, if I want 11, 12, 16 and 17, I will come here and write both the arrays, but the range should be index number 1 to index number 2 plus 1. That is index number 1 to index number 3. And if I run it, I get 11, 12, 16 and 17. Now to concrete your understanding, let's check on with a 3D array. So here I have a 3D array. So to check a dimension of the array, just count the number of opening and closing brackets. As it is a 3D array, you will have 3 opening and closing brackets here. Now in this 3D array, we have 2 2D arrays, and inside each 2D array, we have 3 1D arrays. So let's try indexing on this. I will let R3. Here first I will specify which of the 2D array I want. Let's say we want to fetch the number 24. So I will get inside the 0th array, and inside that 0th array, 24 is in the first array, and inside the first array it is on the index number 1. If I write 1 again and run it, I get 24. So as we know, in this 3D array we have 2 2D arrays. This 2D array is on index 0 and this 2D array is on index 1. So we selected the 0th number 2D array And then inside this we have 3 1D arrays with index number 0, 1 and 2. Here we selected the array on index number 1. Here 24 is on index number 1. So if I write 0, 1 and 1, I can fetch 24. Let's try to fetch this 31. So here I will select the array on the position 1. Inside that, as we need 31, we will need the array on the position 0. So I will write 0. And inside that I will give the position of 31, that is 0, 1 and 2. If I pass 2 here and run it, I get 31. So this is how you can use indexing on a 3D array. You can also work with negative indexing. I will write array3. Let's say I want to fetch out 28. So it is the last element of the first array. So I will write 0, comma, the last array in the 0th array and the last element in that array, that is 28. If I need 37, which is the last element of the first array, I will just write here 1 and run it. I will get 37. Now let's see slicing. Let's slice 33, 34, 36 and 37. So I will come here and write array3, array number 1 from row number 1, comma, from column number 1. And if I run it, I get 33, 34, 36 and 37. Let me explain you this. So when I have to fetch 33, 34, 36 and 37, I will select the array number 1, as this is the array number 0 and this is array number 1. I will select array number 1, and since I have to give a range, I will use a colon, and first I will select the starting range, that is the array on position 1 and array on position 2, as we need elements from both these arrays. And after colon, if I specify nothing, it will take up to the end element, comma, we will specify the columns, that is column number 1 and column number 2. So if I write 1 colon, so it will take the column 1 and 2 both, and similarly it will give out 33, 34, 36 and 37. Now we have mastered how to access specific elements using indexing and how slicing allows us to work with sub-arrays. We also explored the power of multidimensional array indexing, which is one of the important skills to master while working with arrays. If you are still not clear why we choose arrays over list, watch the video to the left. And to understand the basics of NumPy, click on the video to the right and I will see you there. Till then, keep learning and thanks for watching.